So let us now also solve this C bit, which says that find population mean. We have to determine population mean, and we have to show that population mean, which is designated as mu, is equals to the sampling distribution of mean. So x bar SDM. So this is what we have to prove in this C bit. So let us prove it now. So if we see the sample, so if we see the population, so the population basically consists of four numbers, so 10, 20, 30 and 40. So these are the four numbers which are there in the population. So if we determine this population mean, which is represented as mu, so it will be equal to the sum of all values divided by the number of values. So it is equal to 10 plus 20 plus 30 plus 40 divided by 4, which is nothing but, if we sum it up, it will be 100 divided by 4, which is equals to 25. So the population mean, that is mu, is equals to 25. And we have also got that the mean of the sample distribution of mean is also equals to 25. So x bar SDM, which is also equals to 25. So hence we prove that mu, that is population mean, is equal to x bar SDM, which is equals to 25. So this is the thing we have proved. Now we can also prove that the standard deviation of sample distribution of mean is equals to the sigma, that is standard deviation of the population divided by under root of n. So let us prove this property. So this is property second. So in the previous lecture I have explained you about the different properties. So this is second property, and this is property first. So this is first property. So first property we have already proved it. So let us prove now the second property. So standard deviation of the population. So we have to determine standard deviation of the population. So standard deviation of sampling distribution of mean, this we already know. This we know. Now we have to determine this thing. Okay. So let us determine now. So standard deviation formula, as we know, is x minus x bar whole square into s divided by n, which is whole under root, isn't it? So now let us put the values in this. So it will be sigma, we will take this as on the other side, so it will become sigma square, which is equals to, now 10 minus mean is 25 whole square, frequency is 1 only, so 1 plus 20 minus 25 whole square, frequency is again 1, plus 30 minus 25 whole square, frequency is 1, plus 40 minus 25 whole square, frequency is 1. So whole divided by total number of observations in a total number of values in the population are n equals to 4. So we have 4 numbers. So capital N basically represents the size of the population. So N, capital N, represents size of population. Small n basically represents the size of sample. Size of the sample. So divided by n, which is nothing but here 4. So if we solve it, we are going to get 125. So sigma square is equals to 125, and sigma will be equals to, so sigma is equals to under root of 125, which is nothing but your, it will come out to be 11.18. It will come out to be 11.18. So this is the value which we will get for sigma. Okay. Now we have to prove this property, that is sigma SDM is equals to sigma divided by under root of n. Now we have got this sigma as 11.18. So we'll put the value of sigma here. So sigma divided by under root of under root of n, that is size of the sample, is equals to 11.18 divided by under root of 2. So it is equals to 7.9. So it will come as 7.9. And we have earlier determined the standard deviation of sample distribution of mean. So it was equals to, so here we have determined in the previous question the standard deviation for sample distribution of mean is 7.9 here. So it is now proved that, so here also it is 7.9. So which proves that sigma, hence proved, sigma SDM is equals to sigma divided by under root of n. So this is nothing but equals to sigma SDM. So hence we have proved all the properties. So hence proved all the properties we have proved through this question. So hope you like this video tutorial. So in the next lecture we'll be talking about the testing of hypothesis and estimation. Thank you for now.